In this video we're going to look at how to solve linear inequalities. When we're trying to solve a linear inequality, we can treat it in much the same way as we do with an equation. However, if we multiply or divide by a negative, that will reverse the sign of the inequality. So looking at this first example, I'm going to first of all add 2x to both sides. And then I'm going to subtract 8. And then I'm going to divide through by 5. And by convention we rewrite these with x first, so I'm going to have to reverse the inequality sign. So x is less than 13 over 5. And I'm going to represent this graphically using a number line. So 13 over 5 is somewhere between 2 and 3. So I'll call that 0, 1, 2, 3. 13 over 5 would be represented here. And I use a circle to represent its position, and I use an arrow to represent if it's less than or greater than. Now this second example is going to look at how we notate it when we have a less than or equal to sign, and how we can differentiate between that and just the less than sign. So the second one, I'm going to begin by expanding the bracket, and I'm going to collect the x terms together, and I'm going to move the negative 10 across. And then I've got a negative, so I'm going to divide through by a negative, and that reverses the direction of the inequality sign. So I'm going to represent part of a number line, so this is at x is negative 7, so just going to show part of a number line. So the circle is going to be at negative 7, and it's showing that x is greater than that. So I put an arrow going in the positive direction. And because it's greater than or equal to this time, I'm just going to shade that circle, and that shows that it can be equal to negative 7 as well. Now this third equation, this third inequality even, I'm given two inequalities, and we're looking for a solution which matches both of these. So the way I'm going to deal with that is I'm going to solve each one individually to start with. So this first one, I'm going to add 3 to both sides, and then divide through by 2. And the second one, so I'm going to expand the bracket. I'm going to subtract the x from both sides and subtract 6 from both sides, and then divide through by 2. And then I'm going to go back and I'm going to use a number line. And the values I have here are relatively low, so I'm just going to use a partial number line. So this first inequality is x is greater than 5 over 2, so I'm going to represent that on a number line. And the second inequality, or second part of it, shows that x must be less than 3. So what I need to indicate is which region actually satisfies both of these. So values greater than 5 over 2 satisfy both, but only up until x equals 3, where this one won't be satisfied anymore. So when I rewrite this as an inequality statement, I'm showing that the value of x must lie between 5 over 2 and 3. And because these do not have lines under it, I haven't done any shading in the circles here, and it means it cannot be equal to 5 over 2 and it cannot be equal to 3. It lies lies between the two.